the Tata Zest and Tata Bolt, two cars that are absolutely essential, crucial really, to Tata Motors' revival in the Indian car market. Now, while those cars have been designed and developed for use in Indian conditions, a lot of their design, development and process engineering has happened here at Tata Motors' European Technical Centre at the University of Warwick here in the United Kingdom. Tata Motors' European Technical Centre, or TMETC, was established in 2005, predating even Tata Motors' acquisition of Jaguar Land Rover. The idea behind establishing the centre at the University of Warwick in the UK's auto manufacturing heartland was to give the company access to a global workforce with the skill sets, experience and competence required to jumpstart Tata Motors' drive to provide world-leading products.
It was established at the initiative of Mr. Tata and Mr. Ravi Kant at the time. Consideration was given to should there be an acquisition of an existing engineering services company, but the decision was taken to create the organisation organically. TMETC is part of the global R&D network, so it's an inherent part of the overall Engineering Research Centre capability, and it very much complements the Centre of Mass in India. So we're established to provide support to the company in India, as you mentioned, bringing a global perspective to some of the activities, providing a location which has enabled us to recruit from many nationalities, European and others as well.
Amidst all the buzz and activity, however, I was particularly interested in taking a closer look at the centre's contribution to Tata's newest products, the much-awaited Zest and Bolt. Now, the TMETC is not exclusively focused on new product development. They also develop a lot of processes that are used to improve both the quality and durability of existing cars, and one of those processes is the use of the lab car. Now, essentially the lab car is a test bed for a vehicle's electrical systems. All of it comes here. Every part is connected, tested to ensure that everything works as it's supposed to work, and once that's done, it then moves into the production cars.
We've developed the techniques of circuit-based electrical design, which allows us to go from the basic circuits required by the vehicle all the way through to the 3D expression of the electrical distribution system and the harness. And those tools and techniques are shared across the geographies. Again, we initiated the lab car to allow us to validate physically that digital development prior to prototype phase. And once again, that technique's adopted in India and has been applied to Bolt and Zest.
You know, you've talked about how the company's gone about improving quality and durability of the products, but a lot of this is obviously process driven. How much of an influence has centers of engineering excellence like TMETC had in that regard?
So I think there is an enormous influence of all our centers of excellence, and the reason is very straightforward. To get the right quality, we have to build it in right up front, and that's something which we've done, for example, in Bolt and Zest. And it also helps us in putting in place our basic processes for manufacturing, etc., which ensures that we get the right kind of vehicles out there.
TMETC has also been developing expertise in computer-aided engineering across all its activities, and this has been especially key in the areas of thermal simulation and developing vehicle dynamics and chassis simulation. It may seem hard to believe, but these computers can model and develop the driving dynamics of real cars.
The really clever part is not so much the application of the tool, which, frankly, anybody can do. It's interpreting the results and understanding how to express those into the vehicle, how you apply those outcomes in a low-cost and manufacturable way, as well as the optimization of the technique itself. A good example that you saw yesterday was where we've taken a proprietary chassis dynamic simulation software, and we've developed our own additions to that to model the contact patch and the way the car interacts with the road.
As well as new car development and process engineering, TMETC is doing pioneering work in future technologies, collaborating with other UK-based agencies in the Warwick Manufacturing Group piloted Energy Store Catapult. This research group, that is also supported by the UK government, is working to develop breakthrough battery technology for electric vehicles.
It allows us to bring together enough technologists to gain critical mass and command of the technology, and we do that in collaboration with Warwick University itself and with our colleagues at Jaguar Land Rover. And it means that where individually it'd be very difficult to create that critical mass in a relatively novel technology. By combining our efforts with government support, we're able to create, I would say, a Europe-leading facility.
While the team at TMETC is developing battery technology for a new generation of electric vehicles, some of that know-how has already filtered through into a working prototype called the Manza Rev, or Range Extender Electric Vehicle. Now what this is essentially is you have an electric motor that's driving the front wheels from a battery pack that's based in the boot, and additionally what you have is an auxiliary generator that runs off a petrol engine that provides range extension. So you can run fully electric for about 55 miles, and then after that the auxiliary motor will kick in and continue to generate electricity to drive the car even further. One of the key pillars of Tata Motors' Horizon Next strategy is sustainable technology. And while certain elements of green technology like stop-start could make their way into Tata cars in the near term, range extenders and full hybrids may still take some time to hit Indian roads. I know that TMETC are doing a lot of work on EV technology and range extenders and battery technology and all of that. But give us a sense of by when do you think this technology and these operations will filter through into cars that you'll be selling in the Indian market?
Well, I think it's a difficult call to make exactly how the market is going to develop. I think worldwide the evolution of electrified drivelines and electric vehicles has been quite slow, much probably slower than people expected. But so our strategy has been quite simple, and that has been to work across all of the areas of electrification of the driveline, from mild hybrid to fuller hybrid and to range extended vehicles, so that we have the technology available with us. And then as the market opportunities arise, we can work very quickly to introduce those into the marketplace.
While it is facilities like the TMETC that will provide key impetus for Tata Motors' comeback in the Indian market, all eyes remain on the two new cars that will launch in the next few months. How important are these two brand new flagship products to the next phase of Tata Motors and the rebirth of Tata Motors, if you like?
Well, it's been a challenging time for the industry and for us. We've been focusing on the basics and getting the fundamentals right. So we've been fixing our quality, we've been fixing our supply chain, we've been fixing our dealer network, ensuring that we are well positioned to take advantage of these new vehicles when they come out. Bolt and Zest are extremely important for us because they start the new wave of vehicles which we'll bring to market, and it's something which will be quite compelling from a consumer point of view, and we are setting ourselves up for this.
Sporting modern design cues, an impressive feature list, and the new Revitron petrol engine, the Zest and Bolt are the first offerings from the new Tata Motors. And if they appeal to the Indian car buyer, Tata Motors may well see itself on the road to a comeback.